to.
My roommates come around the corner.
So real quick, I want to give a real quick 5-minute aside, not even 3-minute aside, on the nuts and bolts of what the machine is about to do. Because we're going to let the machine do all the crunching for us from here on out. But I always want to take a quick aside to show you what's going on statistically. The reason we're not going to actually do this by hand, well, you'll see that in about 2 minutes of the 3 minutes. So you guys already know what a test statistic looks like. In any test that we do, any test statistic looks the same. You take your sample average, whatever it ends up being. Now, for up till now, it was p hat. All last week, it was p hat. And your quiz this week, it was p hat. Now it's going to be x bar, because we're talking about an average instead of a proportion. But it's still an average, still a sample mean. You find the difference between that and your assumed population mean. So Corey, to come back to your awesome question that you asked about 10 minutes ago, based on just this part of a test statistic, it looks like we're underestimating 3 inches. Because our average appears to be lower than the assumed average of 3 inches. So that right there looks to me like we're under. Fair enough? But the problem is, we don't just stop by looking at that, because what haven't we talked about now? Margin. We haven't talked about the margin in our sample. And that's why the last part of any construction of a test statistic always is a division by the standard error. So there's always 2 things in any test statistic being compared. It's the difference, and then weighting the difference by the margin. This is always going on behind the scenes. Just so you know, it's always going on behind the scenes. And the reason is graphically, what's so cool about it graphically, if we swing over here, compared with our example,